Hello, seventh graders. Today we've got 7.1, which is on mean, median, mode, and range. This should be a little bit of a review for you. I'm guessing you've seen a little bit of this. You were introduced to it in fifth grade. You spent a little bit more time on it last year in sixth grade. So we're going to go pretty quick through this section. And if you need more help, be sure to come ask. We're going to start with some vocabulary. The mean is the sum, remember sum means add, the sum of the values in a set of data divided by the number of data items in the set. Sometimes this is also known as the average. A lot of times people say find the average. What they are saying is find the mean. Add up all your numbers and divide by how many there are is essentially what that is. The median is the middle number. The middle number. Or the average of the two middle numbers. Sometimes there's not one middle number, but there's two middle numbers. So you have to find the average of those two middle numbers in an ordered set of data. So make sure that's important when you're finding the median, you order your set of data from least to greatest. I'll write that reminder in, least to greatest. Right? The mode is the number or numbers that occur most often. The number that occurs most often. If there is no numbers that occur with the same frequency, then there's no mode. So like, I'll just write down sometimes if no numbers repeat, there can be no mode. Sometimes on an assignment you'll see this and you might just have to write down no mode because there's no numbers that occur most often. The way I remember that is mode, M-O, and most, M-O. They both start with M-O. The range is the difference between, so subtracting the difference between the greatest and the least value in a data set. So let's say you had numbers 2, 5, 9, 16, and 18. The range would be your greatest number, 18, minus your smallest number, 2. 18 minus 2 would be 16, would be your range. And lastly is outlier. And an outlier is a value much greater or much less than other data. How can I word this? A value much greater or much less than other numbers in the data set. Let me give you an example. If we're talking about test scores, maybe we say there was a a 98, a 96, a 90, 95, and then a 62. 62 would be an outlier because it's much lower than all the other numbers. So I know it's kind of a lot of vocab words here, but like I said before, I'm sure you've seen these before, and hopefully it's a little bit of a review. All right, let's take a look at the first example where it asks us to find the mean, median, mode, and range of our data set. So the first, what it wants us to do first is find the mean. Okay, remember the mean is like the average, and how you find them, you first add up all the numbers. So 4 plus 7 plus 8 plus 2 plus 1 plus 2 plus 4 plus 2, you see they wrote that out here, equals 30. And once you have them all added, you divide by the sum of the number of items. So how many numbers did we add together? 1, 2, 3, 4, 5, 6, 7, 8. So we would take 30 divided by 8 to come up with 3.75 is our average or our mean. Okay, add your numbers and divide by how many numbers there are. That's how you find the average. The median then is you line up your numbers in order. So least to greatest. And you'll see here they did that. They did 1. There's 3 2s. There's 2 4s, 7, and an 8. So there should still be 8 numbers. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And when you have an even number of numbers, you're going to have two middle numbers. So here's how I do it. I scratch out my smallest and my greatest, and I work my way towards the middle number. Smallest and greatest, the next smallest and the next greatest. And I'm left with 2 numbers, right? So I have 2 middle numbers. It's 2 and 4. So since there are 2 middle numbers, find the average of these 2 numbers. Okay, we just did that. To find the average, you take the numbers added together, so 2 plus 4 would give you 6, and then you divide by how many numbers there are. Well, there's just 2 numbers here. So 2 plus 4 is 6, and 6 divided by 2 would be 3. So the median is 3. And that makes sense because if you had a number line and you had 1, 2, 3, 4, 5, and so on, and you said your middle 2 numbers were 2 and 4, well, what's in the middle of 2 and 4? It's 3, and that's the same as we got there. Okay. Let's scroll down here for the mode and the range. Remember, the mode is the number that occurs the most, M-O-D-E, M-O-S-T. M-O-M-O is how I remember that. The value, what occurs the most, the value 2 occurs 1, 2, 3 times. So the mode is 2. And the range, remember, you just need to subtract or find the difference of the least and the greatest value. So my biggest number is 8. If I subtract 1, 8 minus 1 is 7. So the range of this data set is 7. All right. Go ahead and flip to example number 2 on the next page. And here they start off by giving us a line plot. And the x's represent how many times those numbers occur. So we've got 1, 2, 3, 4, 5 4s. You can see they have that written up there for us. They bring up a marker here, and we'll try it out. It says, the line plot shows the number of miles each of the 17 members of the cross-country team ran in a week. Which measure of central tendency best describes these data? And justify your answer. So measure of central tendency, that's just saying is the mean, median, or mode the greatest number? So is the mean median, or mode best represent or describe this data? Which one? And then say why. So first, you should actually find your mean, median, and mode. So for the mean here, it's kind of nice. They added it up for us. They took 4 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5, and so on and so forth. And they came up with 153 and divided it by how many numbers there were. There are 17 X's here, 17 members of the team. So 153 divided by 17 would give you 9. So the mean best describes the data set because the data is clustered fairly evenly about these two areas. So 9 is right here. You can't really say that 4 or 5 or 6 describe how many miles the cross-country team very well because there's all these other team members who ran 14, 15, 16 miles. So when you have two clumps of information, it would be probably best to find the average of them for good representation. The median, if you lined up your numbers from least to greatest and you found the middle number, let's see if we can do that here. Cross out a small and a big and work your way towards the middle. Lots of data points here, so it's a little bit longer. The middle number, the median, is 6. Does 6, if I said 6 is a good representation of this data, would you agree with me? Hopefully not, because there are 1, 2, 3, 4, 5, 6, 7 kids who ran 14 miles or more. And if I said, most of our team members ran 6 miles, I just don't think that's a very accurate statement. So the median does not best describe the data set because many values are not clustered around the data value 6. Lastly, let's find the mode. The greatest number of X's occur at the number 4. There are the most 4s. Okay, the mode is 4. The mode focuses on one data value and does not describe the data set. Okay, like I said before, there's a lot of team members who ran more than 14 or more miles. If I said 4 represents this data the most, I would highly disagree with that statement, just because of so many of the members up here. So the closest or the best measure of central tendency to describe this data would definitely be the mean, like we said up above. All right, we will wrap up with example 3. All right, finishing up here with example 3. It says the data shows Sarah's scores for the last 5 math tests. They are 88, 90, 55, 94, and 89. Identify the outlier in the data set. And remember from our vocab, the outlier is the data point that's either a lot higher or a lot lower than the rest. So in this case, the one that's a lot lower than the rest is 55. Maybe she had just a bad day. Maybe she didn't study for that test, something along those lines. It says, then determine how the outlier affects the mean, median, and mode, and then tell which measure of central tendency best describes the data with the outlier. So we're going to figure out the mean, median, and mode without the outlier. So we're going to keep 55 out of our data. And then we're going to do it with the outlier. So we're going to keep 55 in our data. And then we're going to see how does that affect our median? How does that affect our mode? How does that affect our mean? All those types of things. So without the outlier, to find the mean or the average, add up the different numbers that we have. So 88, 89, 90, 94, and divide by how many? Okay, in this case 4 because we got rid of this one. So if you do that, 361 divided by 4 will give you an average of about 90.25. And that's about right. All of these are close to 90%. Now, if you calculated that her average with 55 in there, so that low score, if you calculated her average score, now it would be 415 divided by 5, 416 divided by 5, and that would give you 83.2. So look at how much just one outlier can affect your data. There's a difference of about 7 there by just having one outlier in the data. So it can really affect your average. How would it affect the median? Well, without the outlier, it'd be 88, 89, 90, 94. That's from least to greatest. So the median, find the middle numbers. So between 89 and 90 would be 89.5 or 89.5. Same thing you would get if you averaged these two numbers, added them, and then divided by 2. For the median with the outlier, if you kept 55 in there, our data from least to greatest would be 55, 88, 89, 90, 94. And then find the middle. The median would be 89 with the outlier. And without it, it's 89.5. So in this case, the median didn't really change at all. The mode, which number occurs the most? There's no mode with the outlier or without the outlier. So adding the outlier did what to the mean? Well, it decreased the mean. When we added the outlier, it decreased the mean from 90 to 83. So it decreased the mean by 7.05 if you were to subtract those two. And the median decreased by 0.5 from 89.5 to 89, decreased by a half. So what does that say? Well, there's no mode with or without the outlier. The blank best describes the data with the outlier. Which one of these numbers, mean, median, or mode, best describes our data with the outlier? Well, I would have to say the median best describes the data with the outlier. And you'll find that actually a lot of the times that's the case, because when you have an outlier, it really drops or increases your average. An outlier really drops or increases your average. But if you only have one outlier, it most of the time doesn't do a whole lot to your median. So your median is usually your best data or central tendency measure when we're dealing with outliers. All right, that does it for the examples. Try the last problem here on your own. Please pause the video now to try to check it out. All right. You should hopefully have come up with these answers. For the mean, it is 4.25. The median is 4.5 or 4.5. The mode, the number that occurs the most, is 5. And the range, the biggest number minus the smallest number, so 8 minus 1 is 7. If you didn't get those answers, please double check with me or with a table partner so that you do know how to get the correct answers. And that concludes the first section on mean, median, and mode. So I'll see you next time.